Hello everyone, my name is Shion Salve and this project is titled as GeoGuard AI, an AI-powered disaster damage assessment platform using satellite imagery. This project was developed as a part of my term project in BSc Honours Data Science and Artificial Intelligence program at Indian Institute of Technology, Guwahati. The primary objective of this project is to automate disaster damage assessment using satellite imagery and artificial intelligence. Instead of manually analyzing thousands of satellite images, GeoGuard AI performs severity, disaster severity, generates AI-powered reasoning, and automatically creates professional reports. Before discussing the solution, let's understand the problem. Following a natural disaster, such as an earthquake, floods, or etc., emergency teams need a rapid information regarding the extent of damage. The traditional assessment methods rely on field surveys and manual interpretation of satellite imagery. These processes are time consuming and may require several days before rescue teams receive accurate information. In many situations, damaged roads, communication failures, and hazardous environment further delay assessment. Although existing AI models can generate segmentation masks, they typically stop there. They do not explain the severity of the damage, provide does not provides the proper recommendations or generate documentation for decision maker. So GeoGuard AI addresses this limitation by combining semantic segmentation, structured disaster assessment using large language models, reasoning, and automated report generation within single end-to-end platform. The project was designed with five primary objectives. The first, to detect damaged buildings using fine-tuned SegFormer semantic segmentation model. Second, to transform a raw segmentation outputs into structured disaster severity, impact, and confidence metrics. Third, to integrate Google's Gemma 2 large language model for integrating executive summaries, priority levels, and emergency recommendation. Google's Gemma 2 is to 9b was used here using the with the help of Ollama. Fourth, to develop a complete web application using a fast API backend and uh, React TypeScript frontend. Finally, to automate the generation of professional HTML and PDF assessment reports after every prediction. Now, end-to-end system workflow. This slide illustrates the complete workflow implemented in GeoGuard AI. The process begins when a user uploads a satellite image through React frontend. The image is transmitted to Fast API backend, where the pre-processing is performed before passing the image to the trained SegFormer model. The model generates a semantic segmentation mask that identifies the damaged buildings. The prediction is then processed by disaster assessment engine, which calculates damage severity, impact, confidence, and priority. Next, Google's Gemma large language model generates an executive summary together with emergency recommendation. And finally, the system automatically generates HTML and PDF reports, and all results are displayed within the interactive dashboard. Now let's look at the dataset and technology stacks used for this project. The primary dataset is XBD, which provides paired pre-disaster and post-disaster satellite imagery together with building damage labels. I also use OpenEarthMap to improve land cover understanding and contextual scene information. Finally, Sen1 Floods was incorporated to expose the model to flood-related imagery and support future multi-disaster extensions. The trained model performs 5-class pixel-wise semantic segmentation and produces prediction mask with resolution of 1024 by 1024 pixel. From a technology perspective, the vision model is SegFormer implemented using PyTorch and Hugging Face transformers. Gemma 2 is executed locally through Ollama. The backend is developed using Fast API, while the frontend uses React, TypeScript, Vite, and Material UI. Let's look into the system architecture. The system consists of six major layers. The first layer is React frontend, which provides pages for image upload, dashboard, reports, downloads. The frontend communicates with the fast API backend using REST API. The backend exposes prediction, report generation, download, and health check endpoints. The core processing layer includes image pre-processing, SegFormer interface, and disaster assessment engine, AI reasoning using Gemma 2, and report generation. The output consists of prediction mask, overlay images, HTML reports, and PDF reports. Finally, all generated files are stored within the local system for visualization and download. This modular architecture simplifies maintenance and allows future replacement or enhancement of individual modules. So, looking at the model training results, the model was configured to train for maximum of 50 epoch. Training converged successfully after 43 epoch through the implementation of early stopping. The validation mean intersection over union achieved during the training was 0.531. The model also achieved a validation pixel accuracy of 78.2% and validation die score of 78.2%. These results demonstrate stable convergence and consistent segmentation performance. The tensor, the graphs which are being obtained through tensor board illustrate the progressive improvement of validation, die score, and pixel accuracy through training. Now let's move to the project demonstration, how our project is coded and how it performs the activity, how it runs and everything in this project demonstration section. So here we are at our project folder. This is our project folder, AI disaster damage assessment, where this consists of backend, docs, front end, sample images, screenshot, and scripts. So backend, where all the backend work and model training has been take place over here. So it is app configure. These are exceptions, schemas, and everything over here. So this is a backend section. We can see the schemas where API schemas has been shown. This is the land cover, flood, damage, reasoning based model, and all this. This is the code. Engine was developed for the checkpoint of model training. For model training, the engine was developed to check the checkpoints, damage losses, flood loss, loggers, and metrics optimizer were uh, made. So this is the optimizer code. This is the metrics code, and particularly a GeoGuard engine was also made, particularly an folder was dedicated for GeoGuard. So this is the engine result config and everything, inference intelligence. So this is the backend section. Now moving ahead with the front end section. So front end consists of mainly two folders of public and source. So in source we have asset components, hooks, layout, pages, service, styles, theme, and everything which is related to the front end and operating and looks of our website or the web app is it contains in front end. So this is the source asset components which consist of uh, many things, and this is the main app tcx uh, tsx. So this is where our this is the code. Okay, now I would like to demonstrate the project. The backend is already in running, and now we will going to this is app. This system is locally and it has not been deployed over any platform, so it is on the local host on this device only. So I'm running the command now. So this is the website which has been uh, this is the localhost website. Now we will open this. So here we are at our front page of our the front end or the GeoGuard AI platform. So this is the home page. We will now click on start assessment. Here we are going to upload disaster image. So uploading, this is the image. Upload by running AI assessment. Now assessment is running, so it takes few seconds or sometime a minute to give us the answer or generate the response. So it is analyzing the satellite imagery. We will wait for a few seconds till we get the response. So here we got our results. So AI disaster assessment results. So here we get this four major results: severity, impact, confidence, and priority. So here severity is very low because um, I am going to explain further. So severity is low, impact is limited, confidence is 10, and priority is low. So AI visual analysis. So here is the original image which have been uploaded by us. This is the original image. This is the AI prediction, and this is the damage overlay. So AI has predicted these are the building areas, and in green, which the green buildings which have been marked with the green means there is no damage found or detected, and in the red there is some the buildings are destroyed or damaged. So it predicts with red. So what our AI disaster analysis say? The executive summary says the preliminary assessment indicates a lower severity disaster with limited impact. The vast majority of buildings, 98.03% reported no damage, with only small percent of experiencing minor to major damage. So this is the detailed analysis, emergency recommendations, and whatever. Is there any need of urgently attention to this matter, or we have some time or not? Everything. Whether the power supply, assess the critical infrastructure, activate emergency response protocols as necessary based on, and everything are recommended. Emergency recommendation. And this is the damage statistics: no damage here, minor damage, major damage, and destroyed is 0.15%. So here is the download center where we can download our prediction image. So this is prediction image which have been seen, this prediction image HTML. So download HTML report. So here is the HTML report of this GeoGuard AI digital, and this gives us proper. It also takes the images over here. It is taking little time. Then PDF report. So this is the report in the PDF form. It shows all: executive summary, situation analysis, assessment, damage statistics, recommendation, and priority level. So this was our project demonstration. Coming back to the home now. So this was our project demonstration. So let's move ahead with our project demonstration. Next slide. So this slide shows the result generated by GeoGuard AI for a sample satellite image, which we have seen in our uh, model, which has been demonstrated just before now. So on the left is the original satellite image, and the center image shows the semantic segmentation prediction mask generated by SegFormer model. Green regions represent undamaged buildings, while red regions indicate detected damage. The right image is known as damage overlay, the prediction on the original satellite image, making the detected damage easier to interpret. For this sample, the disaster assessment engine classified the scene as a low severity with limited impact, a confidence score of a 10%, and medium priority. The structured assessment was then passed to Gemma 2, which generated an executive summary recommending additional verification before operational decision making due to an low confidence score. Now, moving ahead. Discussion strengths and limitations. The experimental evaluation highlights several strengths of the developed platform. The pixel accuracy and dice score closely agree at 78.2%, indicating consistent segmentation performance. The platform explicitly reports confidence scores, enabling the AI reasoning engine to provide cautious recommendations when prediction confidence is low. The entire pipeline from image upload to report generation is fully automated. Additionally, the use of multiple dataset improves generalization and reduces dataset bias. However, the current implementation also has certain limitations. The model currently focuses on building damage assessment and has not yet been evaluated on wildfire, landslide, or flood specific prediction tasks. The application is presently deployed only on local systems, supports one image at a time, and has not been evaluated under challenging conditions such as heavy cloud cover or low resolution imagery. Now, moving ahead to the conclusion and future work. In conclusion, GeoGuard AI successfully integrates semantic segmentation, structured disaster assessment using large language model reasoning and automated report generation into a single AI powered platform. The project demonstrates how modern computer vision and generative AI can be combined to support disaster management workflows. Looking ahead, future work will include extending the system to additional disaster types, integrating geographic information systems, deploying the platform on cloud infrastructure, incorporating live satellite imagery, performing temporal change detection also the previous disaster and post disaster, and developing a mobile application for emergency responders. Thank you for watching this presentation. GeoGuard AI represents an important step towards intelligent AI assisted disaster damagement assessment using satellite imagery. If you would like to explore the implementation, the complete source code is available on my GitHub repository and the full project report provides additional technical details. Thank you once again for your time and attention.